This is 7th grade, Module 6, Lesson 14 on checking for identical triangles. All right, so we've been talking about classifying identical triangles in class and using those tack marks to kind of help us to see the congruent sides and congruent angles. All right, so we have these two triangles here that are squished together. They share a common side. This is called a common side, which means they're also equal. So if I have a tack of 1 and a tack of 2, this would be tack of 3. So what I'm going to do is actually separate these out so we can see them a little better. So if I separate them out, and of course I'm not drawing these to scale here on a tablet, but you kind of get the idea. This is a 1, that was my 2, and that was my 3. And then they have one going this way. And this is my W here, my X, and my Y. And this is my 1, my 2, and my 3. All right. So are these ones identical? And we're going to say yes. But if you notice, the tack mark 1 here is now over here. So what they did was they kind of rotated it. So you want to go 1, 3, 2. Okay? And if they rotated it and they flipped it. So they rotated it and then they flipped it around. So 1, 3, 2. So that's how you can tell if it's been turned or changed in any direction. Okay? So this was a flip over and then they turned it. But when you put it together, the two ends, the two threes will come together and create a common side. So yes, these are identical. And the condition here is that all 3 sides match. Match, congruent, whatever you want to say there. All right, let's try the next one. So you have these two triangles that are here put together. Now you have one tack mark, one tack mark. You have one angle measure here, one angle measure here. They do share a common side, but I don't know the lengths of either of those sides. I don't know if they are all going to be, they could all be ones. I don't know. Because there's not enough information here, I can't say that they're necessarily identical. Some of it's identical, but not all of it. I can't guarantee it. So we're going to put not necessarily. Identical. Some of it is, but not all of it. So we're going to say the angles correspond. Those equal. And there's also a pair. So they have a pair of equal sides. Oh, that's sides. Sorry, my pen slipped there. Of equal sides. They do share a common side, but as I mentioned, there isn't enough information. So just having this, it doesn't confirm or determine. This information does not determine if it's a unique triangle. There's just not enough information there. All right, let's go on to number 2. Okay, we have this one here. Now, I don't have any tack marks on this one. I do see that I have this angle is equal to this angle, and I have a 90. Now, if this side is 90, so is this side. So with those two angles, I have two angles that are a pair and match. This can be identified as identical. Now, I do have enough information here, even though I don't have any side lengths. So we're going to say identical because two angles correspond and there is an opposite angle given. And that opposite angle given is that 90. So what does this mean? I have two correspondings, that's E and G. Those are equal. And then the opposite angle, so the opposite of G and the opposite of E is this angle F. And they gave it to us by writing that right square in there, so we know it's a right angle. So it's identical. All right, example 2. Example 2, I have some check marks here. So this check mark matches that check mark. And then I have 2's here. And then I also have identical angles here because these are vertical. Remember, vertical means the same. So yes, this is identical. It is turned and then flipped over, but it's identical. So we say because 2 sides and, I'm going to use our big fancy word here, included angle are congruent, or let's say are corresponding, since that's the word we're using in class. Are corresponding. So we have 2 sets of sides, 2 pairs of sides, and then our included angle is what's in between those 2 sides. See how this angle is between those 2 sides, and this angle here is between those 2 sides? That's the definition of included. It's between. All right, let's go on to the back. Okay, I have a couple tack marks here and a couple angles. I see that this here is equal to this down here because there's 2 tack marks. And I see that there's 3 arcs here and 3 arcs. 1, 2, 3. 1, 2, 3. So I have 2 sides and 2 angles that are definitely identical. And then if you notice, I have a set of verticals here. So a set of verticals also make those identical. So 2 sets of angles, 1 set of sides, we're good. So we're going to say identical because 2 angles and a side opposite a given angle are all congruent, which makes this identical. So 2 angles being this one and the vertical, and then the opposite side, so opposites here, those are opposite sides of a given angle, are congruent. All right, I'm going to have you try 4. Okay, so if you need to pause the video and give that a try, go for it. This will be one that I grade. And then I'll meet you on number 5. Okay, for number 5, we have 2 triangles here, 2 right triangles that are kind of put together. I have a 90 here, and I have a 90 here. And then this side corresponds with that side. So they also share this common side. So I can actually put 2 tack marks there because those are also going to be shared. So I have 2 sets of sides and 2 angles. So that's enough to make it identical. And we're going to put 2 sides correspond and the non-included, which means it's not in between, angle. So let me show you what that means. What does non-included mean? So here's my angle measure I'm talking about right here. Is that between these 2 sides? No, it would have to be over here for it to be included. So because it's not between these 2 sides, it's called a non-included. So let's try 6. 6, I have this angle is equal to that angle. This side is equal to that side. And there's a common side. So I'm just going to put a 1 tack mark there. Is that enough? Well, I don't have an exact measurement, or I don't have another angle. I need something. I need another angle, or I need another measurement here to be completely certain. All right? So what we do have here, we do have some things that are identical, but not everything. So we're going to say on this one is not necessarily, and I'll explain why. So not necessarily identical. We're going to say it has equal sides and equal angles and a common side. Like I mentioned, it has all that. So why is it not identical? So let me explain. All right. The two sides and the non-included, which means it's not between those two sides, angle. So looking at those, I have two sides, but my angle is non-included. It's not between them, okay? Is not enough to determine, so it doesn't determine a unique angle for one reason. Whoop, that's supposed to say unique. Let me fix that. So not a unique triangle, mostly because, do I know how big that angle is? No. Now, 5 up above, let me come up here to 5. 5, we had similar thing. And you're probably thinking, well, 5 worked. That's because those were 90s. I knew they were 90s. I don't know how big that angle is. So I can't be certain that they are going to be 100% congruent. Okay? Now, those are 90s and these sides are equal. I had to have at least something that was certain. Okay? In this situation here. All right. You guys are going to do 7 and 8 on your own. So that concludes this video tutorial.